Hello everyone, we're starting a new lesson, force and pressure motion. This is the lesson that we are starting today. Let's understand what is motion. Now in our day-to-day life routine, you must have experienced that we see some objects that are at rest and there are some objects that are in motion, like birds fly, like fish swimming, planets move around the sun. Right, and we see many other things, like for example tree and a house. So these objects are in the state of rest, whereas a bird or a car that is moving, okay, they are in the state of motion. So these are some of the examples of objects at rest and objects at motion. Now when we define what is motion, it is an object that is to be in motion when its position changes with time. So an object is said to be in motion when its position changes with time. There are four types of motion: translatory motion, circular motion, rotational motion, and repetitive motion. Let's understand about translatory motion. There are two types of translatory motion. The first one is rectilinear motion and the second is the curvilinear motion. So we'll be understanding about these two types of translatory motion. Let's see the definition. It is a motion in which an object moves in such a way that every point of the object moves the same distance in same time. Okay, let's see the first one, rectilinear motion. Now when an object shows translatory motion along a straight line path, it is said to be in rectilinear motion. Like you can see a vehicle, right, moving along a straight line path, or a ball is rolling along a straight line path. This type of motion is rectilinear motion. Let us understand about the second type of translatory motion, that is curvilinear motion. Now when an object shows translatory motion along a curved path, it is said to be in curvilinear motion. Let's see some examples here. A giant wheel. I hope many of you must have seen a giant wheel. You see that it is moving in a curved path, right? Let's see the second example. Sea waves. I think some of you must have seen sea waves, or in television you must have seen. You see that the waves are moving in a curved path. And the third example is a curved track. Now when an athlete is running in a curved track, they are moving in a curvilinear motion. Let's understand about circular motion. Let's see what's the definition of circular motion. It is a motion in which an object moves along a circular path. Okay, it moves along a circular path. So the movements of the moon around the earth and the movement of the earth around the sun, these are some of the examples of circular motion. You will see some examples. It can also be when satellites are moving around the earth, right? It's a circular motion. Or the earth moving around the sun and the moving around the earth, right, in a circular motion. Then these are termed to be moving in a circular motion. I hope you have understood till here. Let's understand about rotational motion, and let's see what's the definition of rotational motion. Now it is a motion of an object that turns or spins about a fixed axis. Okay, and let's see some of the examples of rotational motion. The first one is a spinning top. You can see that it is moving in a fixed axis, And the second example that we can see is the rotation of Earth on its axis. All of you know that the Earth rotates in a fixed axis. And the third example is a potter's wheel. This potter's wheel is used to make objects made of clay. Some of you must have seen this. Now these are some of the examples of rotational motion. I hope you understand this, and I hope you have understood this. Let us see the difference between the circular motion and rotational motion. What are the differences? Let us see first about circular motion. Now, in a circular motion, an object as a whole travels along a circular path. Remember, the object as a whole, like you can see in your bottom part of the screen, right? An object as a whole travels along a circular path. Now, what about rotational motion? In rotational motion, the object spins around a fixed point. Okay, it spins around a fixed point. You can see that this wheel is spinning around a fixed point. So this is the basic difference between circular motion and rotational motion. I hope you have understood till here. Let's understand about repetitive motion. Okay, repetitive motion. Let's see what's the definition of repetitive motion. It is a motion which repeats itself. There are two types of repetitive motion, periodic motion and non-periodic motion. These are the two types of repetitive motion. Let's understand about periodic motion first, and let's see the examples of periodic motion. You know that the Earth takes about 365 days to complete one revolution around the Sun, right? It's a periodic motion, 365 days. It's a fixed time that the Earth takes to make a complete movement around the Sun. And a moon takes about 27.322, or we take it as 27 days to orbit around the Earth. Right, this also is a periodic motion. It's a fixed periodic motion, that is 27 days. So these are some of the examples of periodic motion. Let us understand about simple pendulum. Now, a simple pendulum, you can see the diagram on the screen. A simple pendulum, it consists of a small metal ball, which is called as bob, and that is suspended by a long thread from a rigid support that you can see on your left hand side S, such that the bob is free to swing back and forth. The second diagram, the bob is swinging. The bob is free to swing back and forth, like you can see in the diagram. The motion of pendulum was first studied by Galileo. A simple pendulum, it completes every swing, which is known as oscillation, in exactly the same time, provided its length is kept constant. So by this we understand that the period of oscillation of a pendulum is constant. So this is the basic understanding about a simple pendulum. Now let us understand some terms related to simple pendulum. The first term that we'll be seeing is the length of the pendulum. What is the length of the pendulum? It is the distance from the point of suspension to the center of bob, okay, which is termed as length of pendulum, which is represented by capital L. And the movement of the bob depends on the length of the pendulum. You can see that if the length is shorter, the movement is quicker. If the length is more, then the movement is slow. All right, now the second term, oscillations. One complete to and fro movement of the pendulum bob is called as oscillation, and one oscillation is counted starting from one of the extreme positions of the bob or from the central position, like you can see from A to B and then B to C and C to A, or from the extreme position B to the other extreme position C and back to the central position A. So this is about oscillation. Let's see the next term, that is amplitude. As the pendulum oscillates or swings to and fro or back and forth, the maximum displacement of the bob from its mean position on either side is called the amplitude of pendulum. Maximum displacement, right? You can see on the diagram the extreme position from the center position or the mean position is termed as the amplitude. I hope you understand this. The next term that we'll be seeing is frequency of oscillations. What is it? It is the number of complete oscillations made by a simple pendulum in 1 second. That is what is frequency. Using a graphical understanding, the number of oscillations made in 1 second. From this point to the point that I'm marking, that is one oscillation. Okay, that is completion of one oscillation. And from that point that I'm marking, from the third to the third point is the completion of second oscillation. And from the third point to the fourth point is the complete third oscillation. So to understand it better, if we just curve this part to the left hand side, now we can see that there is one complete circle, right? That's what a complete oscillation is. So by this we know that there are 3 oscillations in 1 second, and the SI unit of frequency is hertz, which is represented by Hz. 1 hertz is equal to 1 oscillation per second, and frequency is denoted by small n or f. The next term that we'll be seeing is time period. It is the time taken by the pendulum bob to make one complete oscillation. Okay, that is what time period of the pendulum is, like from A to B and from B to C and from C to A. Okay, graphically you will also understand it below. When the movement is from A to B, B to C and C to A. Now the time taken by the pendulum to complete one oscillation, that is what is known as time period, and the time period of the pendulum is denoted by the letter T in capitals. Now the formula for the time period of a simple pendulum, let us see the formula. The formula of time period is 2 pi into capital L by G, root of capital L by G, where 2 pi is constant and capital T is the time period of simple pendulum. Pi is a fixed or constant value, 22 by 7 or 3.14. Capital L represents the length of the pendulum and G represents the acceleration due to gravity. So this is the formula for the time period. I hope you understand this. You can go back through the video and see it again to understand it.